All right, so we're going to work on a heating curve here. You guys see the question here. It says draw a heating curve for the substance beginning at negative 80 degrees and ending at 170 degrees Celsius. The heat of fusion is 54 kilojoules per mole. The heat of vaporization is 110 kilojoules per mole. The melting point is negative 27.3 degrees Celsius, and the boiling point is 94 degrees Celsius. Okay? The very, very first thing we need to do is just get all this information. Okay, that's what we need to find out, and we simply doing it by reading it. There's nothing hidden here. It's all very straightforward. Draw a heating curve for a substance beginning at negative 80 degrees Celsius. Negative 80 degrees Celsius. And ending at 170. So ending at 170 degrees Celsius. The heat of fusion is 54 kilojoules per mole. So the heat of fusion, 54 kilojoules per mole. The heat of vaporization is 110 kilojoules per mole. The melting point is negative 27.3 degrees Celsius, and the boiling point is 94 degrees Celsius. You guys see that that is simply bookkeeping. Okay? There's nothing to figure out. I'm just writing everything in a very organized fashion without all the other writing. Okay? So continuing, this is what we need to do. We're going to plot our points from left to right by increasing temperature. This is a heating curve. Okay? So I want to plot from increasing temperature from left to right. That means I got to find the lowest temperature, and these are the four temperatures. The lowest one is negative 80. Well, it makes sense. That's the beginning temperature, so that counts as the first point. The next highest temperature is the melting point, so that's the second point I'm going to plot. Again, I'm just numbering the order I'm going to plot them in from lowest to highest. Remember, it's a heating curve, so we're going from lowest to highest temperature to show the increase in temperature. The boiling point's the next highest, and the end temperature is the end one. The beginning and end are always going to be 1 and 4. Okay? These are 2 and 3 in the middle there. Okay? So, as it says up there, we plotted the points, or that's the points we need to plot. Okay? So let's create our little diagram here. And we're going to go, let's say from here, from there to there. And this is freehand, so it's very quick. Let me zoom out a little bit so you can see it all the way. There we go. It's freehand, so it's very quick. This is not like graph paper or anything. These are quick drawings, okay? So plot the points from left to right by increasing temperature. The first one is negative 80 degrees Celsius. We're going to put that on the bottom here. Okay, so that's going to be around right here. So negative 80 degrees Celsius. Okay, because this gives us the range. Okay, these temperatures up here give us the range of your y-axis, so you know how to make, how wide you need to make it, so to speak. Range of the y-axis. Okay, so on here is the negative 80, and the top, it's going to top out at, let's say, 170. Okay, so again, these right here create the range for your y-axis, the beginning and end temperature. Okay, so that's why I put 170 at the top here, and this value, negative 80, is at the bottom. That's our range. Okay, so here we go. Let's plot the points. The beginning temperature is at 80 degrees negative, so it's around right here. And I plot from left to right. Okay, I plot from left to right. The next number 2 up here, is negative 27.3. So I find we're around negative 27.3. Let me kind of clean this up. If 170 is there and 80 is there, that means 0 is somewhere right around there. Again, this is very quick. Negative 27.3, somewhere right there. Okay, so I'm going to plot it just over to the right, just a little more than the first dot. Okay, the third point is at 94 degrees Celsius. Okay, so I go back to the drawing. So I would say 94 is probably roughly somewhere right there. Again, this is eyeball, real quick. Don't take forever. Just get it done. So 94.3, and I go across somewhere in this area. Okay. I know it looks like a straight line. It just happened to be that way. I'm not doing that on purpose. It just seems to be working out that way, just the way I'm spacing it out. You can space them further and out. It takes a little time to get used to it, okay, to get to the perfect drawing, if you can make one. End temperature is at 170, so I'm just going to pick that somewhere right there. Okay, so there's my 4 points plotted from left to right in increasing temperature. Okay, so the next thing I have to do is connect the dots. Okay, it says there, connect the dots. So the first thing I connect from 1 to 2. Okay, look at the screen. Here's my first dot to the second dot. I connect. Then it says plateau from 2. Plateau means a straight line like that. Plateau from 2 and then diagonal to 3. So there's my plateau. I'll make the dot a little bigger so I hit it better right there. Okay. And then step 3 says plateau from 3 and diagonal to 4. So there's that. And I diagonal again. Okay. So that's all I do to connect the dots. Okay. The other thing you need to be aware of is your delta H values. Okay. So I'm going to scroll back on this. These are your delta H values. There's something you need to know about this that you got to try to do. Sometimes the drawings don't come out perfect. As far as these plateaus, okay, make larger value wider. Whoops, wider. That's a crazy way to write wider. I'll just rewrite it. Wider. So plateaus make larger value wider, okay? So out of these two, 110 kilojoules is the bigger number. So that should be your wider plateau. Okay. All right. So I've connected the dots. I've done all the groundwork. So now I just got to do what's next. Okay. So if I look at my notes, I've connected the dots. Okay. And now my labels that I need. Okay. I need a y-axis title and unit. Okay. So that's going to go over here on this side. The y-axis title and unit, we're going to put temperature in degrees Celsius. Okay, so there's one label, temperature degrees Celsius. Okay, x-axis title. All I need to put here is time. I know it says units, but there is no unit because we don't really specify. Time is good enough. You just have to have that there. Okay, the next thing is the 3 phases. Okay, that means solid, liquid, and gas. I need to label these in the proper spot. The diagonals are where you label what phase it's in. Okay, the diagonals represent those separate phases. Okay, and think about it. Okay, think about a piece of ice. A piece of ice is very cold. It's a solid. But as the ice warms up, then it becomes a liquid. And then it becomes eventually a gas because you vaporize it. So that's the same. That if you ever forget, just remember that. The lowest diagonal is going to be for your solid. So I just put solid right there. The middle diagonal is always liquid. And the highest diagonal is always a gas. It doesn't matter if it's a heating or cooling curve. The highest diagonal is a gas. The middle one's a liquid. And the lowest one is a solid. Obviously, in a cooling curve, the stair steps are going the opposite way, but you'll get the idea. Okay, so there's my 3 phases. Then it says I need 4 labeled arrows. Okay, 4 labeled arrows. So when I take a piece of ice and I go from solid ice to liquid ice, that process is called melting. Okay, there's 1 labeled arrow. If I go the opposite direction, so in other words, from liquid to solid, that's called freezing. Okay, so there's 2 labeled arrows. Okay, continuing. If I go from liquid to gas, sometimes this one's hard to remember, but remember, liquid to gas is evaporation. Okay, it's evaporation. So that's what we're going to write it as, evaporation. That's how most people remember. Okay, liquid water evaporates to a gas form. The opposite is condensation. Okay, the opposite is condensation. So there's my 4 arrows. Okay, and the last thing is the delta H values for the plateaus. I have my 2 plateau values here. Here's the way I remember, because you're going to say, well, which one is which? See vapor right here, VAP. Match it up to the VAP here. So this is the delta H of vaporization. That's that plateau, and you just write the value, just right under it, 110 kilojoules per mole, just like that. And then that means that this one is the delta H of fusion, and that's at 54 kilojoules per mole. Okay, and now you're completed. Okay, that's all you need to do to get 100% on this problem. Okay, you did all the drawing, you connected the dots, label with unit, y-axis label with unit, x-axis just label. Okay, solid, liquid, gas. There's my 3 phases. Here's my 4 arrows. Remember, the arrows are on the plateaus because they describe the process. As the liquid evaporates, it becomes a gas. That's kind of how you read it. As a solid melts, it becomes a liquid. Okay, that's kind of how you read these values. And in the end, like I said, whether it's a cooling curve or a heating curve, let me see if I can put these side by side as best I can. They look pretty similar, okay? It's just an opposite stair step, okay? But in the end, it's pretty much exactly the same. Okay, so that's how you do the heating curve. If you guys have any questions, let me know.